In this tutorial, I'm going to introduce you to several tools I've found to be very helpful. This first one is called a nibbler. Back when there was a Radio Shack, they carried the nibbler, and I almost always had one of these in my toolbox. Here you see the nibbler tool, and on the left, just below the tool, you see metal shavings, or nibbles, that the nibbler chomped off of the aluminum seat pan for the plane. The nibbler was able to cut out very small pieces of metal to give the seat pan a little better look where it had to go around one of the seat supports. It's not perfect, but it is much nicer looking than when I had cut the aluminum with tin snips. Being more careful than I was can provide a much cleaner look. The nibbler can be used on all sorts of materials, not just metal. The next tool is a heavy-duty hole punch for making holes in sheet metal. This tool is used to make what are known as speed holes in the sheet metal. You don't need to purchase a full multi-hole cutting kit like I have here. I used the 1 1/4 inch hole cutter on my seat and on the backrest. You can cut any size holes you wish as long as you've got a die for it, or even none at all. The idea behind speed holes is to keep the plane as light as possible. Honestly, it's not really much of a savings, and I'm talking a few ounces at best. It does give the plane a slightly more finished look. However, the sheet metal will most likely be covered by some sort of cushion. Since it's not a mandatory use on the plane, the call to purchase and use the tool is up to you. Along with the hole punch kit, you may wish to purchase a flared hole dimple die tool. This tool presses the edge of the hole into a flared hole. This helps to provide strength, gives the hole a finished look, and also, in most cases, eliminates the sharp edge left by the hole cutter. Here's an example of what a seat looks like once the speed holes are put into it. The hole pattern can be anything you would like. You only need to be careful not to put too many or too large of holes in the sheet metal itself. On the flip side of that, it's pretty amazing just how much metal material can be removed without causing failure of the seat. The seat and backrest pans are normally held in by pop rivets. I didn't care for this idea since there is a chance that the control cables that go under the seat will need to be inspected or repaired at some time in the future. By using a rivet nut, screws can be used to hold the seat parts in place and allows for the screws to be removed so access to the control cables and other parts under the seat is possible. Rivet nuts come in many different sizes. I decided to go with the same size as the pop rivets that are normally used. This is 3 millimeter. So there are the 4 different tools that I used in this tutorial. These come in handy in other places, and you may notice that most of these or similar tools were used to create the same effects on kits and RTFs. Such as with the nibbler, I cut off sharp 90-degree or larger angles on sheet metal. This or something similar is used to make such a cut on the seat pan for RTFs. In the back, on both left and right sides of the seat pan, are 45-degree cuts. The 45-degree cut gives the sheet metal a cleaner look. The hole punch or knockout is used on RTFs. It's left up to the kit buyer to do this for their aircraft if they wish to do so. The same goes for the hole flare or dimple. For RTFs, this has already been done for the buyer on their seat. For kits, it's up to the buyer to do this. I do recommend for kit buyers to do the flare if they decide to do the hole punch. The flare smooths the edge of the hole and prevents cut injuries. Most people, at one time or another, know how much fun a metal cut can be. The nut rivet is already used on kits as well as RTFs. Just look at the mount area on the left of the plane in the cockpit. You'll see a large nut rivet which is used to hold the plane's throttle. So let's move on and get to something like this at the end of this tutorial. For the nibbler, all I can tell you is that it makes the sheet metal look cleaner. Take your time, because once a piece is cut, it's done and gone. There is no going back. To use the 3mm rivet nuts, the tab rivet hole in the cockpit seat frame must be enlarged. The tool came with a guide showing that the 3mm rivet nut needs a 5.0 to 5.4mm hole. Look at all the tabs that will hold the seat pan in place and the backrest and drill them out to 5.x millimeter. I drilled out to 5.3 millimeter and it worked well. The smaller the hole is, the more difficult it will be to get the rivet nut to pop. Once drilled out, do not put in the rivet nuts yet. Put the backrest and seat pan in place on their respective tabs. Make sure they are squared properly. Use some clamps to hold the sheet metal in place if needed. Use a Sharpie to mark where holes need to be drilled for the 3mm screws used to secure the sheet metal in place. Tap the Sharpie marks with a nail or a punch to keep the drill bit from walking. Drill the holes with a 3mm or number 30 drill bit. Once done, put the backrest and seat pan back into the plane. Verify the holes in the sheet metal align up with the holes in the tabs. Next is the fun part, making this into this. Next, follow the instructions for your rivet nut gun. I did find that if I left a small gap between the top of the rivet nut and the mandrel, using the gun was much easier than screwing the rivet all the way to the mandrel. Put a rivet nut into each mounting tab. Be careful though, I got one rivet nut in slightly sideways. The rivet nut had bent when I had popped it into place, which caused a 3mm screw to jam up inside the rivet nut. The 3mm screw then broke when I tried to get it out. I had to drill the rivet nut out, which isn't difficult, but a little time consuming. I recommend after installing all the rivet nuts to run a 3mm screw through them. I purchased round top hex or Allen head screws to use. If a screw starts to bind, back it out a few turns and then try again. There seems to be some debris from popping the nut in place that can cause issues. Some WD-40 or other oil or cleaner may clear out the threads if you wish to try that. Once all rivet nuts are able to be screwed in, remove the screws. The next step is cutting the speed holes in the sheet metal. I made a pattern of where I wanted the holes to be in the sheet metal. I then used a punch to create an indent. This helps to prevent the drill bit from walking to a location where you don't want the hole. Next, I drilled the hole for the punch tool. I placed a board under the sheet metal to help with the drilling process. Notice the hole isn't perfectly round. That's okay. This entire area will be removed with the punch tool, so it won't matter. Now put the receiver end of the punch tool on one side of the sheet metal. It doesn't matter what side, this is only punching the hole. All punch kits I've seen emphasize the need to grease the tool on each use. Make sure you do that or you may strip out the threads, making the tool useless. Now screw on the cutting bit. Now screw the cutting bit down to the sheet metal. You're not cutting the sheet metal yet. The bit only needs to be touching the sheet metal. You can see that the bit is just touching the sheet metal. Now turn the sheet metal over. My kit came with a ratchet wrench. All I had to do was tighten the bolt, and it pulled the cutting bit into the receiver. This cut the hole very easily. The next thing I knew, there was a hole right where I wanted it. Unscrewing the receiver from the cutting bit showed two pieces of sheet metal. Where there wasn't a hole, there was now. Now I emptied the sheet metal from the receiver and did the process as many times as needed to punch all the holes I wanted. Now it is time to dimple or indent the punched holes. Place the curved portion of the tool into the side that your behind or your back will be against. This will bend the sheet metal to the back for the backrest or bottom where your behind is, away from you. Double check each time you put this tool on the sheet metal. There's no going back if by accident you get one of the holes reversed. Now screw the back part of the tool on the side that the dimple will bend into. Use a wrench, or like I did, use a slow turning drill and tighten the bolt. My drill has an impact setting which allows it to release tightening the bolt when a set amount of force trying to turn the bolt is reached, but it no longer can turn the bolt. This means that the bolt was as tight as it's going to get and the dimple creation was done. This also prevents the drill from spinning out of your hand, the sheet metal spinning and cutting into you, or stripping the bolt. Just take your time. This tool works great and it's really easy to use. Now back the bolt out and remove the top and bottom of the tool. The dimple will be created. Do as many of these holes as you wish, or none at all. It's totally up to you. You may have noticed this ugliness in some of my pictures. This is what happens when you remove the plastic protection long before you're ready to mount the seat and the backrest. Both were damaged by the salt water in the air here in Florida. This can be removed, but it takes a lot of work with 1,500 to 5,000 grit wet dry sandpaper and a lot of auto rubbing compound, followed by auto aluminum polish and then auto paint polish. The last polish is here to help prevent the damage from happening again. I spent a full day getting these two sheet metal panels clean and shining again. I still have more work to do on the backrest. You can now put your screws in and secure both the backrest and the seat. Remember, the screws don't come in the kit, you have to buy them. I did use 3mm stainless steel washers to give the bolt a little more surface area on the sheet metal to prevent any cracking of the sheet metal. The fuel tank is cumbersome to mount, but is also straightforward. Find your mounting brackets and screws, washers, and nuts for the fuel system. Test install the mounts, leaving the nuts fairly loose so you can do a trial fit of the tank. The tank mounts to the back of the frame just behind the seat. You'll find you'll need to drill the holes for the bolts in the tank brackets. They are not pre-drilled. The good about this is it allows you to move the tank up or down on the L brackets that it mounts to. I preferred to mount the tank high on the brackets. It really doesn't make a difference, so you decide what you like. You may have to cut the brackets. The part that mounts to the L braces are pretty long. I ended up cutting the top ones and making them short and leaving the bottom ones the full length. I also angle cut the top and bottom L braces. I didn't like the way they looked out of the kit. This approximately 45-degree cut doesn't weaken them enough to be a consideration. Initially, I used clamps to hold the brackets to the L braces. I removed the brackets after marking where I wanted the bolt holes drilled and drilled the holes. I then reclamped the brackets back on the L braces, slid the tank into place, and used a Sharpie to mark where I needed to drill the bolt holes in the L braces. Once you have the holes drilled, install the bolts, add the tank, and then tighten the bolts. You may find gaps in the bracket and the tank. This is normal. The assembly manual suggests using insulation foam or something similar to help absorb vibration, as well as helping to secure the tank. I put foam on the bottom and the back of the tank, but not the top. The bottom of the tank does not have a groove or channel for the bracket to fit into like the back and top do. I figured the rubber foam on the bottom may help to keep the brackets from allowing the tank to slide left or right. The foam on the back slid right into the channel on the back of the tank. The top I didn't put any foam into. Since there is a channel across the top, I didn't want the foam to push the bracket out of the channel. I reinstalled the tank and pretty much shook the heck out of the plane to make sure the tank wasn't going anywhere. The seat belt goes in really easily. On both sides behind the seat are mounts for the seat belt. As in this picture, the order left to right is nut on the inside of the frame, washer, the bracket on the plane, another washer, seat belt bracket, another washer, and then the bolt. Easy peasy. Bolt both sides and the shoulder part of the seat belt, which reaches over the tank to mount in the upper part of the tail's frame. It uses the same bolt washer sequence. With that, we've just completed putting the seat, tank, and seat belt in. I hope you've enjoyed this tutorial, not only because you've made progress on your build, but because it was a lot shorter than most of the other tutorials. Thanks for watching.